We are given a pretty big circuit here. It's not complex, but it is pretty big and it can look really challenging. So if you cannot do this straight off the bat, there will be in the description, first link below, a link to a video that I did that has a simpler problem so that we can understand the basics of series and parallel circuits and the equation behind them. It's a super quick video, so if you don't understand anything here, go to that one and then come back to this one, because this is a great example and a more realistic example of something we might encounter. So we have a bunch of resistors, and we can start really from anywhere in here and start combining things. What I like to do is look at the left-hand side, and from here, draw out my circuit. What I like to do is start from the left side, the leftmost side, and draw out my current. So the current is going to be flowing through this way. Then it's going to go into parallel, and it's going to go this way, and this way. I'm just going to look at the bottom for now. So then it's going to hit this way, it's going to go up this way, and then it's going to hit this node and go through this way, and it's going to go up this way. Now this gives us a great idea of what we can do to start. The first things I'm going to look at are this current. Normally I would do one thing at a time, but this is super easy. For starters, we're going to look at these two resistors. We can see that they are in parallel, so we are just going to combine them. We're also going to look at this resistor and this resistor. We can see that they are in series, so we are going to combine them as well. So these are the two formulas. We have the total resistant for series, and we also have the total resistance for in parallel. These are the formulas we are going to use. I'm actually going to redraw part of the circuit. I'm going to copy and paste this in here so that we can make it smaller as we go. So first I'm going to look at the 9 ohm and 18 ohm resistor. These are again in parallel, so we're going to use the parallel part. I did make a mistake in the parallel formula. This should not just be an R subscript I. What it should be is a 1 over R subscript I. Now that that's fixed, we can go about doing this problem. And after we plug this into a calculator, we are going to see that we get 6 ohms of resistance. So for this circuit, we're going to have 6. This would just be 10 because we're carrying it over from what we had over here. We're not changing anything right there. But we have 6 for this parallel part. For the next part, I'm actually going to fix what I cut out right here. We have a 20 ohm resistor here. And if we draw this out, we can actually write this 75 ohm resistor like this, instead of it being slanted. That way we can see it a little bit easier. And we're going to have our resistors in series to the right of this. Since they're in series, we just add them together. So this is going to be a 75 ohm resistor. I also read the circuits wrong. This part should not be 75, it should be 50, and this inside one should be 75. Now that we've redrawn our circuit, it's a little bit easier to see a couple things. So it's a little bit smaller. This definitely helps us a little bit. But if we draw our current, we can see that our current is going through our 20 ohm resistor, and is going to split in parallel between this 50 ohm resistor and this 75 ohm resistor. That means this 50 ohm resistor and this 75 ohm resistor are in parallel. It is in parallel to our 20 ohm resistor. This 20 ohm resistor right here is the only way for this current to go through to our 50 and 75 ohm resistor. So what we can do is have our 20 plus our series in parallel. That way we can do it all in one step. This is what our equation is going to look like, and if we plug it into a calculator, we are going to get 50 ohms. So this 50 ohms is going to replace this 20 ohms, this 50 ohms, and this 75 ohms. But it's still going to be in parallel with this 75 ohm resistor right here because the current splits at this node. So I redrew the circuit by hand this time. It's pretty messy, but it gets the point across well. And I'm going to redraw the current flowing through our resistors. It is going this way, then it hits this node and goes in parallel with these 3 resistors. And then it also goes in parallel with this 75 and 50 ohm resistor. So we will do in parallel with these 2 resistors right here. This is going to be our equation, And if we do that, we are going to get 30. So 30 is going to be replacing our 75 and 50 ohm resistor. Once we replace these resistors, we are going to get the following circuit with 30 in here. And now we can redraw our current and see what we should do next. Starting from the bottom again, we can see that it splits in parallel with these three resistors. Looking at this current, we can see that our 10 ohm and 30 ohm resistor are in series. So we can just add them together. After we do this, we are going to just get a 40 ohm resistor. And this 40 ohm resistor, we can see, is going to be in parallel with the 60 ohm resistor because of this splitting of the current at this node right here. So we can plug 40 and 60 into our parallel formula for resistors. So if we put our 60 ohm resistor and our 40 ohm resistor into our equation, we are going to get 24 ohms. After we get 24 ohms as our answer, we are going to replace our 60 and 40 circuits. So I just copied the equation so you guys can actually see me redraw it. So I'm going to get rid of these and then just replace this 60 with our 24. And then we can get rid of the current flowing this way because there's nothing flowing down there. If we look at this circuit now, we can see that we have something else that is also in series. That is this 6 ohm resistor and this 24 ohm resistor. And this is because when the current goes up this way, it goes back this way through this resistor. So we can add them together. When I add them, all I'm going to do is knock this part out and then completely redraw it where we have this line here and our resistor right here. And this is going to be a 30 ohm resistor. It is a rule that is pretty handy to note because it could save you a lot of time, that if two resistors are in parallel and they have the same exact resistance, then the resistor, when combining them, is just going to be half of what that value is. For example, here we have 30 ohm resistor and we have a 30 ohm resistor. That means when we combine them, since they are in parallel, we are going to get a 15 ohm resistor. After we combine all of these, this is what our circuit is going to look like. Now, if we draw the current flowing through, it goes through our 5 ohm resistor, 15 ohm resistor, and then into our 10 ohm resistor. That means these are all in series. And if they're all in series, we can just add them together. So 5 plus 15 is 20, 20 plus 10 is 30. This means that our answer is 30 ohms of resistance. If you want to check any of the work that we did for this problem, these are the steps, going from left and right and down each row. If you found this video useful, consider giving a like. If you want to see more problems like this, you can subscribe and also view the playlist that's linked below. If you have any questions on the material or anything related to the material that we covered in this video, feel free to leave them in the comments and we'll get back to them as soon as we can. And lastly, good luck on your studies. Alright, the whole entire house smells like french fries, except for like this room. Okay.